the third method, that is simultaneous equation method for the overhead distribution. Okay, so this is also secondary distribution for deciding upon the, it is a method used for the secondary distribution. We already learned about the primary distribution, which includes the allocation and apportionment, and in this secondary method we had learned in the last few classes about direct method and also repeated distribution method. So in today's class we would be discussing about simultaneous equation method. And as the name suggests, in this method, the primary methodology used will be solving of an algebraic equation. We formulate an equation, and primarily that equation is to compute the, it is used to compute the overhead cost, total overhead cost of service departments. Now we are talking about reapportionment. We are also discussing about the methods of reapportionment. In those methods, the third method which we are discussing now is simultaneous equation method. Now, as the name suggests, this method involves formulation of a formula, algebraic formula, and solving that for going with the secondary distribution. So listen to me very carefully. I will be showing this with an example. Okay, now this is the question. I have displayed the question in front of you. As you can see, the primary distribution summary in this case is already given. The primary distribution summary of department A, B, C, X, and Y is being given. Now we are asked to go with the secondary distribution summary using simultaneous equation method. Okay. Now in the question, from the question we can understand that the service departments are X and Y, and the production departments are A, B, C. So reapportionment involves charging the expenses of service department X and Y to the production department A, B, C. It is same, there is no difference. But how are we charging? In this question, we are doing with the example of simultaneous equation method. This is the context. Now, as you can see here, the department X, okay, department X, total of primary distribution summary. Department X is our first service department, okay. The total of primary distribution summary of X is 4,500, okay. Total primary distribution summary of service department Y is 3,000. That you have to remember. Then, looking into the reapportionment, we can see that 10% of, okay, 10% of Y's, 10% of Y share is shared with X, and 20% of X share is here with Y. So that is reapportioning. At the time of reapportioning, as we can see, it is 10% of Y's expense also would be done with X, and 20% of Y's expense would be shared with, 20% of X expense will be shared with Y. So this is the primary factors or primary things we will consider while we are framing the algebraic equation. That is, I repeat, the total of primary distribution summary of service department X, the total of primary distribution summary of department Y, which is also a service department, plus it will also include the portion of Y's expense shared with X. Y is the service department. The portion of Y's expense shared with X, as well as the portion of X share shared with Y. These are the two factors which we will consider when we are going with the redistribution based on the simultaneous equation method. Okay. Now let's see how we are going to frame the equation. See here. So as I was explaining, total cost of X is equal to 4,500 plus 20% of Y. We said that X service department cost involves the total of primary distribution summary plus 20% of Y share which is shared with the X at the time of reapportionment. That is, here we assume it is shared with the service department also, but we are trying to solve that using an equation. So here it can be understood that 4,500 is X's own expense plus 20% of Y's expense is also shared with department X while sharing with all the departments. See here, they are sharing with department X, department Y, department A, department B, department C as well as Y. X department's expense being reapportioned to A, B, C as well as to service department Y. Y service department's expense being apportioned to department A, B, C and X. So we are using this part for our algebraic equation. This part, X and Y. Okay. So that is why we said 4,500 plus 10% of Y. Right? 3,000 plus 20% of X. That's what we have put here. Yeah. 4,500 plus 20% of Y, 3,000 plus 10% of X. So Y is equal to, it's like this. See here, Y is equal to, see here, for share of X being shared with Y, it is 10%. So it will be Y is equal to 3,000 plus 10% of X share. Then X is equal to 4,500 plus 20% of Y. That's what we have put here. 4,500 plus 20% of Y, 3,000 plus 10% of. So that's our first preliminary equation. This is the only thing which you have to remember. What is the share of Y being shared with X? What is the share of X being shared with Y? That's all. After that, we are trying to solve this equation to get an answer to Y or X, right? So in this case, in this example, we are first trying to put the, see, this is the same example, same equation being simplified. That is 4,500 plus 0.2Y. It is 20%, so it is 0.20. Right, 20%. So 4,500 plus 0.20Y. Y is equal to 3,000 plus 0.10, that is 0.1 x, 0.1 x. Now, in order to solve this equation, we are multiplying these two, both, okay? Okay, you might be wondering, how did I get this, x? It's as simple as that, x, this part being taken to left side. So, x is already there. When positive being taken to this side, it becomes negative. When it is taken to this side, left side. So X minus 0.2Y is equal to same thing, 4,500. We are trying to solve the algebraic equation as we were doing in our 10th standard and all, no? The same thing. So X minus 0.2Y, which gives 4,500. Then in this case, since we needed x together for solving that, what did we do is, we brought this, it will become negative 0.1x. There is no change in y. So plus y is equal to 3,000. I repeat again, nothing we have done, we have just formed the mathematical way of solving it. So here, x and y, these are the service department. So what we will do, we will actually take, it will be like this, x minus 0.2y, x minus 0.2y, 4,500 was already there. In this case, since we wanted x together for solving it, what did we do? Same thing, we took this to the side, like negative 0.1x minus, plus, y is already there, negative, this becomes negative. So negative 0.1x plus y is equal to 3,000. Okay, that's what we got. This is just writing it so that we can solve it. We want to find the value of y and x. We want to substitute it with the value of y and x. So that's why we are going to do. Now, in order to, this is one method of simplifying it. I'm just showing one method. In order to solve it quickly, what we will be doing is we will be multiplying just to avoid the decimal, just to delete the negatives. We are trying to multiply that with 10. Okay, so here the decimal will be gone when we multiply with 10. So that's what we are going to do in the next step. So first one, we converted that into a formula for solving it into an algebraic equation. So now we have an algebraic equation here. Now we are multiplying with that with 10 to solve the equation, to eliminate the decimals and also the negative figures. Okay, so that's what the next thing is all about. So when I am multiplying that with 10, the same thing. This is the same equation which I had shown. This is our algebraic equation. We framed an algebraic equation. Now when we multiply that with 10, see, this equation being multiplied with 10 means it will become 10x, right, minus 0.20 in 10 will become 2y. 4,500 into 10 will become 45,000. So first equation when multiplied with 10. Now you might ask, why multiplying with 10? Since we had a decimal of 0.2, we multiplied that with 100 to eliminate the decimal. So we multiplied and we got the answer like this. That is 10x minus 2y is equal to 45,000. Now we are going to multiply this equation with 10. Okay, this equation with 10. So in that case, how do we get? We will eliminate this one. 10 into negative 0.1. 10 into negative 0.1 x. 10 into negative 0.1 x will give us negative x, plus y into 10 will give us 10y is equal to 3,000 into 10 will give us 30,000. That's it. We did the first step. So I repeat, initially we framed an algebraic equation, okay, using the information given to us in the question. Then we multiplied that with 10, right? Now, in order to solve this equation, and also we would like to eliminate, convert that into an algebraic equation where we can find the value of either x or y. Here in this case, we took that multiplying the second equation with 10. Okay, we multiplied the second equation with 10. Now, what will happen if I multiply with this first equation? No problem. But here, logically, when we look into this equation, if I want to eliminate one and get the answer for any of these variables, it will be better for me to multiply the second equation with 10. Excuse me. That's why, in this case, I multiply the second equation with 10. So that second equation with 10 means it would be negative x into 10, which gives me negative 10x. First equation, I kept it like that itself. Okay, that is 10x minus 2y is equal to 45,000. But the second equation, I multiplied with 10 for solving it. So negative 10x plus 10 into 10y, which gives me 100y. Okay, so negative 10x plus 100y is equal to 30,000 into 10, which gives me 3 lakh. Okay, now it's very easy for me to solve. By 10x and 10x get 10x and negative 10x gets eliminated. So what I'm having is 100y minus 2y, which gives me 98y. 98y is equal to 3,45,000. Okay, that's the only logic for multiplying that with 10. We were just looking at how to nullify that immediate. Otherwise, we will have to do so many steps. So many steps to get to reach to this answer. If you want, you can do it. There is no issue in that. But we were just solving it in a simplest way. So it will be 98y is equal to 3,45,000. Now I can easily find the value of y. Y is equal to 3,45,000 by 98, which gives me 3,520. Once I get the value of y, it is very easy for me to find the value of x, because in my initial this one I have told that it is 4,500 plus 20% of y. Now I got the value of y. How much did I get the value of y? 3,520. 20. So it is very easy for me. X is equal to 4,000 plus 20% of 3,520. That was given in my question itself. When I took the first example, I can see that X is equal to 4,500 plus 20% of Y. So it is very easy for me. So that's what I have done. Once I got the value of Y, the next step for me is Y is equal to 3,520. I solved it. Now total overhead of X is equal to 4,500 plus 20% of Y. Right? So we know that it will be 4,500 plus 3,520 into 20 by 100. Right? When I solve that, I get the value of X, that is 5,204. So I got the total overhead cost of two service department X and Y. That is for Y, I already solved the equation and I got the answer as 3,520. Then for X, I substituted my value in the algebraic equation and then I got the value as 5,204. Okay, but there is one more which is very clear from my initial example, initial question. See, if 10% is for X, if 10% is, no, this I am thinking, if 10% of, no, when I am going to share it with this, okay, it will be easy for you if you look at this example. See here, I have already said that Y includes 10% of X, which means 90% of X. That will be, that is clearly understood. I'm sharing Y's 10% with X, but the remaining 90% should be with production department A, B, and C. So that should be with the production department A, B, and C, means it should be shared between the production department A, B, and C. The same is the case for X. See, when I look here, I can understand that X includes 4,500 of X and 20% of Y, which means 80% of remaining of Y is shared between production department A, B, and C. It's clear from the question I just showed you the example, but here it is clear from the example. See here, Y, when I look, 20% of the whole expense is with X, but remaining of this 20% should be shared between A, B, and C. So that's what we are going to do in the next step. Okay, that is, we will go with total of X, which we have found out is 5,204. So 5,204 into 90 by 100, which gives us 4,683. That needs to be shared between A, B, and C. And then the overhead of Y, here it is, we have already found out 3,520. So 80% of 3,520 needs to be shared with the A, B, and C. So that means 2,860. This is the total of overhead expenses that need to be shared between A, B, and C. I know that you might be having confusions when I'm just explaining it, but it will be a little more clear when you are doing that. But I'll just repeat it once more before we start doing it. See here. In the question, in this particular question, we did not have to go with the primary distribution because we are given with the primary distribution summary. So we wanted to go with the secondary distribution, which is based on the simultaneous equation method. So as per this method, as I said earlier, we are writing an algebraic equation to solve this. So our first algebraic equation is like this, that is total cost of X is equal to 4,500 plus 20% of Y. Here it is in the question. From here we can see that it is total cost of X. See, X includes 4,500 plus, from the question we can understand that 20% of Y is shared with X and 10% of no, this one, it is X is shared with Y. I'm sorry, 20% of Y is shared with X and 10% of Y is shared with X. Yeah. So that's what I put here. Total cost of Y is equal to 3,500 plus 10% of X. Total cost of X is equal to 4,500 plus 20% of Y. So I just made this into an equation. 4,500 plus 0.2Y, 3,000 plus 0.1X. Okay. Now what I'm going to do is I'm going to form this into, now this is not an algebraic equation. I want to rephrase it into a proper algebraic equation for finding the value of X or Y. I can take the option of finding the value of X or Y here. Okay. So I'm going to do in this way, X minus, when I'm bringing this to the left side, it will be X minus 0.2Y is equal to 4,500. Same as in this case, since I wanted both the X in the same side, I did like this, minus 0.1X plus Y is equal to 3,000. So I got my algebraic equation. Now I'm trying to solve this. So initially, since we have decimals, the easiest method is converting all the decimals into real numbers. So I'm going to convert this into real number by multiplying it with 10. Again, you might ask me why 10? Because here it is a decimal 0.2. The decimal is 0.2. So when I multiply that with 10, yes, I will get a real number. So that's what I'm going to do. I will multiply this with 10. So it will be like this. Yeah, here it will be like this, 10x minus 2y is equal to 45,000. Here in this case, it will be minus x plus 10y is equal to 30,000. Now, for getting an answer, we will have to solve at least one equation. So logically, when we think if I get a 10x here, yes, I can easily get the value for y. That's why what I did is I multiplied the second equation with 10. Okay. So second equation, when I multiply with 10, it would be negative 10x. See, negative x into 10. So negative 10x. First equation I wrote like that itself. Negative 10x plus 10 into 10. 100y is equal to 3 lakh. Okay, so I got two algebraic equation. Now I can solve it easily. 10x and negative 10x cancelled. So what I have is 100y minus 2y is equal to 3,45,000. 100y minus 2y is equal to 3,45,000. So it will be 98y is equal to 3,45,000. Now I can easily find out y. It is 3,45,000 by 98, which is 3,520. I got the answer till here. My part is clear. Now what I'm going to do is I will have to find out a value for x. For that I already have an equation. The equation says x is equal to 4,500 plus 20% of y. So that's what I'm going to do. 4,500 plus 20% of y. So 4,500 plus 3,520, which is the value of y I got, into 20 by 100. So 4,500 plus 704, which gives me 5,204 as the value of x. Now I got the value of x and y. Now what I have to do is I have to think from this perspective. Okay, if 5,204 is the total of x, and if 10% is shared with y, then remaining 90% is shared with the production department A, B, and C. Right. And the second case, if 3,520 is the total of y, and if 20% of that is shared with x, the remaining is 2,840. That is, the remaining should be shared with department A, B, and C, which are production departments. So what I'm going to do, I will find out what is 90% of x and what is 80% of y, which gives me answer of 4,683 and 2,816 respectively. I got the answer. Now it is very easy for me. What I have to do is I have to prepare a secondary overhead distribution summary and distribute these total amount in the ratio as it is given in the question. Say 4,680 is my total for X, and for Y it is 2,816. That needs to be shared between X, Y, department A, production department A, B, and C. Now, in which ratio? How do I know? It's there in the question. For X, it is 4:3:2. I'm going to use this. For Y, it is 3:3:2. I'm going to use this. So that's what I've done. In the last part, overhead distribution summary, I got the total I'm going to share between, this is already given, primary distribution summary, which was there in my question. 6,300, 7,400, 2,800. I just copied it over there. 6,300, 7,400, and 2,800. I copied it there. Now I have to share this with the departments. So 4,683 in the ratio of 4:3:2. Here there is no difference. Whatever we have learned in the previous thing, previous method, the same is done here. We are sharing it that to department A, B, and C. Then overhead of Y, what we had found out, 2,816. It is shared in the ratio of 3,000. 3:3:2. So that is being shared. And total of the production department overhead distribution summary, that is total of primary distribution as well as secondary distribution, will be written as we always do in other cases. So final overhead cost of the production department will be the total of all these. This is as per the simultaneous equation method. So when we are talking about, this is all about the algebraic equation method. So here, in this, what we have to remember here is, we will always be, when you hear this keyword, equation method, okay, equation method, then that has to strike you that, yes, I have to come up with an algebraic formula for solving this. That's the key to that. Direct distribution, we are directly distributing to all until it gets nullified. In case of repeated distribution, again, we are repeating the same thing to get it nullified. But in this method, we have to remember, when an equation being told, we have to frame that into an algebraic equation for solving or for getting the total overhead cost of X and Y, right? Now,